Thanks very much. So hopefully I wasn't playing keyword bingo with the title of this talk and people are actually here and they like Python. Maybe they're touching Kubernetes every day and they don't really like YAML. You're in the right place. But who am I? I'm Elliot Gunton, Senior Software Engineer at PikeKit. We're a startup and I'm a Hera maintainer, and more about that in a second. And quick plug for the company, sponsoring my food and everything. So we help you scale Argo and Kubernetes. So we're working with companies that you get direct support from Argo Workflows maintainers. That saves you engineering time and compute costs. And so the outline for today, what is Kubernetes? I hope people can kind of answer that question. The K stands for Kubernetes. What is Argo Workflows? Maybe you've heard of it or you're curious. And then we'll talk about all things Hera, so focusing on the Python aspect with features and examples, and hopefully a demo that goes smoothly, and the takeaways for the talk today. So what is Kubernetes? How I would describe it to someone who's not really technical, I'd maybe skip the first line, but it's the cloud native standard, but it allows your applications to scale more easily. It's container native, it's got an active and growing community, long-term support, vendor neutral, all the boxes you want to tick when you're looking for software to run on. And what is Argo Workflows? Spot the difference. The last four were the same. It's built on Kubernetes, so you get all the same benefits. And it's kind of won the adoption wars as well to become the de facto workflow orchestration standard for Kubernetes. And that means you're scaling workloads more easily in the same way you're scaling apps on Kubernetes. So why would you even need a workflow orchestrator? It's a bit of a can-do-anything box of tricks that you need to use. Maybe you have machine learning pipelines, training pipelines, you're collecting data, training models, deploying them. It works for all kinds of data processing, image processing, video processing, that kind of stuff, and schedule jobs on that kind of cron schedule. You'll need these kind of features if you're looking at Kubernetes, like scalable resources, automatic retries, and integrated artifact storage, so you don't have to worry about, I just made a thing, how do I get it onto my storage over there? Argo will handle that for you. So diving into the anatomy of a workflow, is a Kubernetes custom resource definition. If you're using Kubernetes, you see these day in and day out. It's a kind of workflow, and then it has these templates, which are analogous to functions in a library. So we have this daemon DAG, and we have this echo container down here. And these templates can be arranged through a DAG. So we're arranging this echo container to be run 4 times through a DAG of tasks. And this entry point up here, diamond, is kind of the main function of the workflow. So the average Argo developer experience is that you've written a YAML of 1,000 lines and you're just bogged down, it's hard to test, hard to reuse anything, and you just kind of get fed up with pull requests that make no sense. And you are thinking, I'm in the wrong place, why is he talking about YAML still? Imagine if you work primarily in Python, you think YAML is funky JSON. You know some buzzwords about Kubernetes like pods, container, cloud native, and you need to run stuff on cloud native. So this was me about 3 years ago at Bloomberg. We wanted to get rid of Airflow clusters and have people running on Kubernetes. So to get them on to Kubernetes, we needed something like Hera, which is the Python SDK for Argo Workflows, so that people wouldn't have to interact with YAML day in, day out. So this lets you write your templates as Python, write your templates as functions, orchestrate them, and test them all in Python if you want. You can interact with the Argo server API just through Python, so it's just an API call. And that gets you the best of both worlds. So Python's got all these great things like developer experience, libraries testing, you get your code completion, it's preferred scripting language for many people, packaging and versioning. And Argo, we got all those benefits of Kubernetes that we mentioned earlier. So we get resource management, we get parallelized workloads and artifact storage integrations. So Hera gives you a seamless all-in-one solution of the business logic is in your Python functions, you have a workflow orchestration of those functions separate, and you can even submit the workflows from Python. And all that is nothing if you don't know how to use it, so we've got extensive documentation. We've got a walkthrough that takes you from zero knowledge through to submitting and using the more advanced features of Hera, and user guides for the super advanced features that need a bit more explanation that can fit in a walkthrough. But that's enough talking, let's see some code. So we're going to take a YAML workflow that we just saw, and we're going to turn it into Hera, just like that. But let's take this line by line. It's making a DAG where we have the A, B, C, and D, obviously by the diagram. But starting with these custom written classes, these are not auto-generated from the Kubernetes spec. These are handwritten that help you get your workflow written more easily. So you get nice code completion, things kind of make more sense. And we have this context manager pattern. If you've used Python, you get to use this with syntax, and then that creates a new context. And that kind of looks like the YAML dictionary format if you squint your eyes a bit. So when you're reading documentation from both sources, if they're using YAML or they're using Python, you kind of can orient yourself. So inside the context, objects are added automatically. The container goes into the workflow, the tasks go into the DAG. And we have a little bit of syntactic sugar sprinkled where on this line we're calling the container template and we're passing the keyword arguments that came from the task just now. So we have name and arguments that just save you some boilerplate. And finally, you're arranging the task dependencies with this right shift operator. If you've used Airflow, then it'll look familiar. And a quick side-by-side, if you still prefer the right, you can leave the room now. So container native is cool, but what about Python native? I was just talking about functions can be your templates, but we're looking at this container, so it's running a image, a command, take some inputs, etc. But I just want to write, or maybe I already have a function and I just want to run it on Kubernetes. And with Hera, all you need is the decorator that says, this is the image I need, run the code inside. And the syntax inside the DAG is exactly the same, so the only thing that's changed here is this function. And once you have that workflow, you need to maybe submit it to the Argo server. That's just a w.create on the end once you've set up the namespace and the workflow service. And let's say this is running on a local host. Then w.create will get it running. And once you've submitted it, you can get an auto-generated workflow object back. You can convert it, but in this example, it's just using the model workflow. You can see the name and the namespace. You can just print some diagnostics if you want, but basically open that and you'll see the workflow running. So you'll see live progress. You see the DAG task details on the sidebar, and you can go through per container logs. So what we're looking at here is an inline script template. So revealing the magic behind the curtain a bit. It's not just give me an image. It will take that image and it's running through it, but Hera adds a little bit of boilerplate to load some input parameters for you, and your function will be pasted in basically. It's exactly what you wrote. But that comes with some problems. So even if I said this is a string, down here, JSON load, if you know how it works, it just takes whatever it sees and then gives you something out, and Python is dynamically typed, so this message could be an integer, it could be a string, who knows? We just trust the user at that point, which is always a bad idea. And when we're running on Kubernetes, this is basically like running a Python file, so there's no returns, and what does this mean? We can't really test this function, we're just praying that it works. So the Hera script runner is a feature of Hera which kind of solves this problem. It lets you run actually native Python functions on Argo Workflows, and all you need is to build an image, and then Argo will pull that image, and Hera runs that code through its module. So what that means is you get these deserialized inputs. They get type checked, so if you try to pass a string as a length, it says, no, no, you're not allowed to do that. And you can also return, and that means you can test. So you might be looking at this if you use Python every day, just like, bro, what? This is like obvious. But in the YAML world, you can't really test templates individually. When it's in a workflow, you need to run the whole workflow on the cluster and say, this ran in this order, you set up the dependencies in that way. Here we've got one script template being tested individually by itself, which doesn't seem groundbreaking, but in the Kubernetes world, it kind of is. So how do you set that up? You just need 2 bits of input. The constructor is a runner, and the image is something that you're going to build. So it's almost a chicken and egg problem, but you write the code, you build from it, and then you run it. And if you've used Python for a bit, you'll know about Pydantic. This is a library that does basically API serialization, JSON to Python and back. And Hera already integrates with Pydantic to get that type check validation at runtime that I showed you. But you can take it a step further and get these custom structured input and output, and then Hera will automatically serialize and deserialize for the JSON objects. So using Pydantic, let's replace this length and width, very complicated business logic, calculating the area of a rectangle with a rectangle class. So what you need to start with is the rectangle class. It's a subclass of base model which comes from Pydantic, and we're going to give it a function on that class. And then simply changing the input here, we are using the rectangle directly within the function. And then we're still testing the template. And if you've got some different output serialization needs, you can also do input deserialization. For the output, we use this special annotated syntax. So this data frame comes from pandas, and you say this is going to be an artifact. And if you don't know about artifacts, that's when your parameter is a bit too big and you kind of want it to go to your S3. And in this case, the function is returning a data frame. So in your tests, you'll say, does this data frame look as expected? But in Argo, when it's running on the cluster, it will dump it to binary format, which Hera can't do automatically in this case because it doesn't know how to interpret a data frame, which is a third-party library. Cool. So what else can Hera do? You can test workflows end-to-end. You can check execution paths and outputs. You can set class defaults and pre-build hooks. So this really helps platform teams. If you've got your organization, you know your image repository needs to be mycompany.com, blah, blah, blah. You can set that up. And you can actually version your workflows and workflow templates. So a quick aside on workflow templates. We said the workflow is like a library of functions. A workflow template is like exporting that library of functions for other people to use. So, with that said, let's see if this works. So if you want to find this code later, it's on my GitHub. And right now, I'm going to show you it working in real life. Okay, so I've got some make commands set up here. So we've got a build and a run. So we get some requirements, we build an image from it, and then we run it. And in this is where we're running. We set these class global config defaults that I just mentioned. So I want everyone to be using runner scripts in this repo. The image is already set as this Hera scratch over here. And then when we create the workflow, we set the namespace, we get a workflow service, which is just the local host. Make sure we don't verify SSL on the local host. And then you create the workflow. So if I run, or build and run, we'll see it builds, and then it runs, and gives me a link. If I click the link, we get a pod spinning up here. And if I prove that it's really on Kubernetes, it should be in here somewhere. Oh, it's already run. It was this one. So we'll see the logs inside here. It said hello world. We see the logs inside here. It says hello world. Success. That's 1 of 5. Right. I haven't even shown you the workflow. So here we've got a script that just prints hello, and then the argument that you pass in. So let's say we want to do it twice. We might want a DAG, and then inside the workflow we'll use that DAG. Oops. We'll set the name as something descriptive. Naming is the hardest problem in programming. We want each task to have a unique name, so we need to pass a name here. We'll pass the arguments as well. So we've got an S input argument over here. And can everyone see this, by the way? We'll go in one more. Okay. We'll pass world here, and then we'll do it again, but this time we'll pass KCD. Right, and now we've changed, well, we want to change the entry point, so we were just calling the script template directly. Now we want to use the DAG. Let's give it a different name, and we don't need these arguments anymore. Right, cross your fingers. It's built, it's submitted. Is it running? There we go, we've got 2 pods running in parallel, and proving again we're running on Kubernetes. Maybe they've already run again. Wow, my laptop is fast today. It wasn't this fast when I was practicing. Yeah, one says hello world, one says hello KCD. If we want the logs from the whole workflow, we go to this tab, Everything is there, as expected. 2 down, I think 3 to go. All right, what am I showing you next? I'm going to add some custom input. So, Pydantic, we need that. We want the base model from it. And let's say we're rating the talks that we've seen today. We're not going to worry about the API, we're just using standard out. Let's say we need a KCD talk class, which is going to inherit from base model. We're going to give each talk a title, which is a string, and a rating of an integer. We don't want this hello anymore. We're going to make something new. So we need this script decorator. I don't need to do anything inside here, but I'll just show you as well. You can add things like labels. Something goes here. Oops. All right, and then inside this, we're going to rate the talk with our API, which is standard out. Rate a talk. And we have KCD talk, which is that. Right, and then our API call looks like that, very technical. I give the KCD talk title, talk, more rating, rating out of 5. Okay, we're going to give it a better name again, rate KCD talks. In the DAG, we don't want this anymore. We're going to rate a talk. Talk 1, I'm very imaginative today. Arguments, my talk is no YAML, no problem. I forgot to give it the, hold on. I need the input of the argument, is KCD talk here. And then I want to use the actual object that I used. Title, there we go. No YAML, no problem. Shout out a rating for me. How is it going so far? If you say anything other than 5. All right. And the talk from this morning was keeping AI honest. I thought that was a 5-star. Cool. That looks good, I think. Rate KCD, yep. Okay, build and run it again. And it's giving me a link, that looks good. We're rating one talk and then the other. It's a bit zoomed out still. Oops. Alright. I give the no YAML, no problem talk 5 out of 5. I give the keeping AI honest talk 5 out of 5, right? That's the custom structured input. I'll show you that here. So that clearly looks like JSON. We're using JSON inside. And because we're using Python, we can do anything with it. For now, how's my time? I'm going to leave that for the moment. And show you some dynamic fan out examples. So now we're going to look more into what you should be using Argo for, which is not toy examples. It's more like, I have all this resource in front of me and I want to use it, so let me just do a load of processing. And what that might look like is in here. I'll copy this out into here. In this one, I'm going to generate some numbers. Let's say we've done a load of number crunching. We've got some S3 file paths. Just use your imagination for a second. And with those paths, we're going to tell the next task to consume them. So if we build and run this one, it will start generating some numbers. And this is actually random, so it's be somewhere between 8 and 11, 12. We've got 10. Cool. And each of these is coming from the result here. So this is a variable which reads the standard out. So if you log anything in here, you kind of break it. So it's good for toy examples, but don't use it normally. And it's finished. Zoom out, I can't see. Okay, cool. Once you've fanned out, you might want to collect your results and bring them back in. And with that, we can use a fan in example, which will look very similar, but we'll collect the results after. Similarly, dumping some variables, receiving them, and then we need to pretend we're processing at this point. Maybe we'll times them by 2, and then you write them out, and then fan-in will collect those again. Let me submit that again, so that we see something change. Okay, but the one that just ran should be finished. Finishing. Okay, that's what it looks like. You've collected all your results together, and you say, cool, you process all the data, and let me notify the next step. Cool, cool, cool. And then if we see in this one, we generated some numbers, 1, 2, 3, or 0 through 9. And inside, we are turning a 4 into an 8. Then the fan-in step receives all the double numbers. Cool. We did some real processing. Now, finally, I mentioned artifacts were when your parameters get too big. So that's a Kubernetes limitation, which is because YAML is not a great file storage system. Who would have thought? You want to actually move those to S3. So in this example, we're using artifacts, and I'm going to show you, hopefully, why Hera needs a script runner, which simplifies everything. So in this example, out of the way, this code is being dumped directly into the YAML. So an artifact in Argo land means you put something in your container, and now you want to get it out of the container and send it off to somewhere else, so that's your S3 storage. And how you do that without the Hera world is you write something to a file, and then in the outputs you say, I wrote something to this file, send it on to the next thing. At the moment it's just exposing it. And if I run this, it will write something to a file in the outputs down here. Any second now. There we go. This out artifact looks like hello world string. Cool. Whoops, something's dying. And then we consume it in the next step. And if I check the logs, you definitely received it as hello world. Cool. But this looks like an absolute pain to write for anyone who's familiar with Python. So what if I told you there was a better way, where you just use this annotated syntax that says, I'm giving you a string, by the way, can you treat it as an artifact when it comes out of the container? And what this means is, inside here, we're just returning a string and Hera, and then Argo will handle the exporting. And in the next step, we're saying, this is a string, by the way, it's an artifact, so it's going to load from that. And Hera will set up the YAML so that Argo understands that there's going to be artifacts coming in and out of the place. So, running this one, we should get exactly the same workflow. So a writer writes something to the artifact, looks like hello world, nice, and then this one's using it, hello world, there we go. Okay, and I think, yep, that was it. Let me go back to my slides and close it out. Cool. Hope you enjoyed that. It didn't go wrong. Okay, key takeaways for today. If you've enjoyed playing with Python, yeah, you don't need to touch YAML. It's great. So don't let it be a barrier to actually using Kubernetes, because Hera exists, Argo Workflows exists, so you can start orchestrating on Kubernetes today. So Hera makes it accessible. And with Hera, you supercharge your Pythonic experience rather than just having another auto-generated SDK. It's specially written for Argo, so you can be on your way happy. Too long didn't read, or you're falling asleep after lunch. Argo Workflows and Hera give you the best cloud-native workflow orchestration experience. So if you want to connect with me, GitHub is argoprojlabs/Hera. We have the docs at hera.readthedocs.io. And on the CNCF Slack, we have a Hera channel, Hera Argo SDK. I'll let you take a photo. And then if you want to read more or hear more from PipeKit, we have more talks and demos on this repo. And I will open it for questions. Thank you very much.